Welcome to today's lecture on data-centric AI machine learning. We will explore how shifting focus from model complexity to data quality can transform machine learning outcomes. Let's begin by contrasting two paradigms, model-centric AI and data-centric AI. Model-centric AI prioritize optimizing architectures and hyperparameters. For example, tweaking neural network layers or gradient descent. Key activities include feature engineering, model selection, and training. But here's the catch. It often treats training data as static, risking overfitting to imperfect dataset. For example, you might be spending weeks tuning a convolution neural network without checking for mislabeled images. Data-centric AI represents a paradigm shift in AI development. The goal is to improve data quality, quantity, and consistency through rigorous cleaning, for example, removing outliers, precise labeling, which is critical for supervised learning, and augmentation, like rotating images to expand the dataset. Let's say the difference. Model-centric AI usually asks, how can we build a better model for this data? It's a one-way street. Data-centric AI machine learning instead asks, how can we build better data for this problem? Creating a feedback loop where data and the models iteratively improve each other. Here's some real-world impact. A fintech startup achieved a 20% reduction in false positives solely through dataset refinement, maintaining the exact same model architecture. So why shift to a data-centric approach? The benefits are clear. First, we can achieve higher accuracy even with simpler models. No need for overly complex architectures when your data is clean and well-structured. Second, development cycles become faster. Instead of spending weeks tuning hyperparameters, you invest time upfront in quality data, which pays off in streamlined training and deployment. Third, your models gain improved interpretability and fairness, as high-quality data reduce hidden biases and makes decision-making more transparent. At the heart of the data-centric AI are 6 core principles that guide how we build and refine systems. First, systematic improvement of data fit. This means using augmentation to expand dataset, actively mitigating biases, and embracing continuous learning to keep data relevant. Second, consistency is the key. We achieve this through automated tools for quality checks and standardized labeling guidelines, because reliable models start with reliable data. Third, it's not a one-way street. Data and models improve together in a cycle. Analyze errors, refine the data, then retrain the model. Fourth, human oversight ensures ethical outcomes. We address biases and focus on real-world needs. Fifth, recognize that AI is social technical, user-centric design and transparency aren't optional. They are foundational. Finally, collaboration is non-negotiable. Domain experts and AI teams must work side by side, maintaining data integrity through constant feedback loops. You can think of it as building a skyscraper. The model is the steel frame, but the data is the foundation. With weak foundation, the whole structure fails. But with these principles, we will ensure both are rock solid. Let's dive into 3 foundational techniques that power data-centric AI machine learning. First, data labeling. This is the backbone of supervised learning. Precise, consistent tags turn raw data into meaningful signals. Think of it as teaching children with flashcards. Garbage labels mean the model learns the wrong patterns. Second, augmentation, where we artificially expand dataset. Simple tricks like flipping images or adding noise can dramatically improve model robustness. It's the equivalent of giving your model a virtual reality headset to experience more scenarios without costly new data collection. Finally, cleaning. Even the best dataset have cracks, outliers, missing values, inconsistencies. This is the data equivalent of preparing a surgical room. Remove contaminants before the operation begins. One healthcare team found 12% of their training labels were incorrect. Fixing them boosted accuracy more than any model tweak. Together, these techniques form a cycle: label well to train well, augment to generalize, and clean to reduce surprise in production. Building robust AI systems start with great data, and these open source tools are your essential toolkits. Let's explore them by category. First, data quality guardians. CleanLab automatically detects label errors and outliers in messy dataset, while CleanVision specializes in finding blurry or cropped images. You can think of them as your data's immune system, flagging problems before you infect your models. For structured data, Great Expectations act as a unit testing framework for your dataset, and Y data profiling generates instance health reports like a blood test for your pandas data frame. On the annotation front, Label Studio provides a Swiss Army knife for labeling everything from text to video. And when you need to surcharge your dataset, Album Mentions often offers industry-strength image augmentation with just a few lines of code. For large language models, Llama Index structures data for retrieval-augmented generation, while DSPy optimizes prompts algorithmically, turning brittle chains into robust pipelines. Here's a pro tip. Start with Y data profiling for exploration, then layer in CleanLab for validation. These tools aren't just nice to have, they are what separate proof of concept from production-ready AI. For those who want to dive deeper into data-centric AI machine learning, here are three essential resources that informs today's lecture. First, the 2023 book, Data-Centric Artificial Intelligence, A Beginner's Guide by Mahala et al. Provides a comprehensive foundation. The book is a perfect fit if you are new to this paradigm. It's available from Springer. For a more technical perspective, I recommend Jaraha et al.'s seminar paper in Communications of the SAM, which details the 6 core principles we discussed earlier. Pay special attention to their framework for human-AI collaboration. Finally, MIT's Data-Centric AI Resource Hub offers free tutorials, toolkits, and case studies, an excellent place to start implementing this concept. See you in the next lecture.